Find the volume of the solid obtained by rotating the region bounded by y equals x squared, y equals 4x minus x squared, about the line y equals 6. Okay, so what do you think we're going to do first? We got to draw the thing.
Should we just pretend that's an axis?
Y equals 6?
Yeah.
Well, it is. What is an axis? It's a line.
Yeah.
It's a fancy word for line.
Yeah.
Although it only has 4 letters, so I don't know why it's fancy. But it's just one we don't use that often.
The word X.
Oh, X, yeah. Words with X, it's just cooler. Yeah. So take a look at the equations that form our region. That one's a very familiar parabola, and then we have to figure out what that guy looks like. Let's figure out where they intersect right away, okay? Before we try and draw this thing, so y equals x squared, y equals 4x minus x squared. I can think of one intersection point just by trial and error.
0,
0, 0, right? If I plug in 0 for x in either equation, I get the origin as an intersection point. So that's kind of nice. So I know that 0, 0 is an intersection point. The other one, I could probably get by trial and error as well. What do you think? 2. Yeah. So it looks like, so if you plug 2 in here, then we get 8 minus 4, which is 4. If we plug 2 in here, we get 4. So 2, 4? Well, I guess we don't have to solve the system. So if it's that straightforward, yeah, don't take time to solve that system. So let's go, well, I can't go over that far. Let's go over like that. And then I'll use a slightly different scale on the y-axis. So 2, 4 we said, right? And then, of course, y equals x squared goes through 1, 1, so I'll graph that one first. So y equals x squared something like that. It keeps going, right? And then y equals 4x minus x squared. If you think about it, you'll realize that the vertex, I think, is actually at the 2, 4. And I think it goes down. Where did if it goes through 1, 3, doesn't it?
Yeah.
Yeah, so that might be a good point to plot. 1, 3. Now, you can always use your graphing calculator, right? So, yeah, I'm doing this in a hurry, but your graphing calculator will do it even faster. Okay? And then clearly, that's going to be the region formed, right? Okay, so what's the difference then? We're not rotating about the x or the y-axis. So this is the x-axis, right? This is the y-axis. We're not rotating about either one of those. No, we're rotating about the line y equals 6. So I can plot that. What does that look like? It's a horizontal line. And so it's parallel to the x-axis, right? The line y equals 6 is parallel to the x-axis. And I'm having trouble drawing a straight line, but I think you get the idea. So here's a representative rectangle. But now when we rotate it, you guys see that there is going to be a hole. So it really is the washer method. So v sub I then is going to be obtained using that formula, pi, the larger radius squared, h, pi r squared h, minus pi, the little smaller radius squared h, once again. Okay, so we're going to subtract out the volume of the hole from the volume of the larger cylinder. But it's these corners. You guys see that it's these top corners this time? When you rotate, or this top edge perhaps, if you want to look at it that way, this top edge of the representative rectangle, that's, when you rotate that, that's what creates the hole, right?
Yeah, it's small.
So let's make sure it's obvious to you what little r is and what big R is. So little r, would you believe, is this distance? Yeah? So what is that? I don't know if I left myself enough room. So little r is that distance. What would little r be? Remember, to find distance, you take the bigger number and you subtract the smaller number. 6 is the bigger number here. So 6 minus what function represents the top or coincides with the top of that rectangle? The one in blue, which is 4x minus x squared. Well, let's say 4, it's a sample point we're plugging in. So 4x sub I, okay, minus, so quantity. X sub I, 4x sub I minus x sub I squared. If you want to use c sub I like I did the other day, that's fine, but I thought you guys might like x sub I better to emphasize we're integrating with respect to x. Oh, by the way, why are we integrating with respect to x?
Because it's up and down.
Vertical rectangles.
Yeah.
That's the easy way to remember it. Vertical rectangles, you're integrating with respect to x. How do I know to use vertical rectangles? The long side has to be perpendicular to the axis of rotation, which is horizontal. Okay? So it's got to be a vertical rectangle. So everybody agrees that would be r, right? Little r. Now what would big R be? It would be that distance, right? Yeah. So, okay, so that would be 6 minus, the curve in red is x squared, so x sub I squared. And that's, I didn't label it, that's capital R. Very important you take your time with these pictures to get the right radii. Okay, now that we've got it, I think we can fill it in easily enough. So v sub I then is going to be pi. Okay, we're going to square this quantity. It was this guy, right? That's the capital R. So 6 minus x sub I squared, don't forget to square it, times h, but h is delta x. Minus pi times, okay, this one's a little longer. This whole thing, quantity squared. So 6, let me use brackets here just to distinguish between the parentheses and the brackets. Okay, so so pi, okay, times 6 minus quantity 4x sub I minus x sub I squared. And then what do we do with that whole thing? We square it. Running out of room there. And then multiply that times delta x. So just to be clear, this guy inside the parentheses is my capital R, and this guy inside the brackets is my lowercase r. Do you buy that? All right. I want to set up the integral and simplify the integrand to emphasize that it's important. Then once you simplify the integrand, it's reasonably easy to evaluate, and I'll leave that to you guys. So let's stick with v sub I and simplify. First of all, I'll put pi on the left side, and we'll factor out. I don't know if that's enough room. Yeah, it should be enough room. And we'll factor out the delta x on the right side. That leaves me with what in the middle? 6 minus x sub I squared quantity squared, right?
Quantity 6 minus 4x sub I minus x sub I squared quantity squared.
Yeah, you got to take your time, make sure you don't miss anything. Okay, there? So then the integral is going to be the volume. Okay, We can pull the pi out, and then it's with respect to x, so think left to right. What's the lower limit of integration? 0. What's the upper limit? 2. Okay, so 0 to 2. And then bracket 6 minus, it becomes just x squared minus, okay, how about, let's rewrite it as x squared, positive, right? Minus 4x plus 6. So I got rid of those inner parentheses anyway. And so I guess that means I could just use, I like to use just parentheses when I can. And then the whole thing squared, and then it's dx on the end. Okay. So there's a little bit of algebraic work to evaluate this. You've got to square those things out. I'm going to leave it to you so we can go take a break. Let me give you the answer. Turns out to be 64 pi over 3. But of course, you have to multiply it out so that you can evaluate it term by term. But again, that's a good exercise for you guys. Okay, cubic units.